March 6, 1944, 28,000 feet above Berlin, the 56th Fighter Group clashed with German fighters in what would become the largest aerial engagement yet witnessed over Europe. Across the vast battle, American Thunderbolt pilots observed something that astonished their Luftwaffe adversaries. German fighters executed their usual escape maneuver, pulling into steep climbs to shake pursuers. For the previous year, this tactic had been nearly foolproof. The heavy P-47 Thunderbolt simply could not match the climb of a Focke-Wulf 190 or Messerschmitt 109. Yet on this March day, everything changed. American fighters remained locked onto German tails through climbs that should have been impossible. At altitudes near 28,000 feet, with both aircraft approaching stall speed, Thunderbolt pilots opened fire. Black smoke trailed from disabled German aircraft as pilots bailed out. By the end of the mission, the 56th Fighter Group claimed 11 German planes destroyed without losing a single Thunderbolt. The transformation was complete. A modification to the Thunderbolt's propeller had removed the aircraft's most critical limitation and fundamentally shifted the tactical balance over Europe. The story of this change began in the engineering departments of two American propeller manufacturers during the harsh winter of 1943. While bombers bled over Germany and fighter pilots reported German aircraft escaping by climbing away, engineers raced to solve a deceptively simple problem. The Pratt & Whitney Air 2800 engine produced 2,000 horsepower, yet the P-47 Thunderbolt climbed poorly. The narrow-blade Curtiss electric propeller fitted to early production models could not translate that immense power into vertical performance. These blades were optimized for high-speed cruise efficiency, designed to slice through the air with minimal drag above 350 miles per hour. During climbs at low airspeeds with the engine at full power, narrow blades could not bite enough air to convert horsepower into thrust effectively. Engines screamed at maximum RPM, consuming fuel and generating heat, yet failing to pull the aircraft upward with adequate force. January 1943, Republic Aviation Headquarters, Farmingdale, Long Island. Alexander Cartelli reviewed combat reports from England with growing concern. German fighters dove through bomber formations, struck, then pulled into steep climbs to escape. Pursuing Thunderbolts could not follow. Performance data was damning. Early P-47 models required lengthy climbs to reach combat altitudes. The Focke-Wulf 190A and Messerschmitt 109G reached those altitudes far faster. This performance gap directly contributed to American casualties. Pilots perished in scenarios where better climb performance might have saved them. Some Army Air Forces commanders questioned whether the P-47 should remain in frontline service. Cartelli understood the engineering problem. Propeller efficiency depends on matching blade area to operating conditions. Narrow blade propellers performed well at high speeds where thin blades minimized drag, but during climbs at low speeds, blades required more surface area to catch air and convert power into thrust. Increasing blade area seemed obvious but proved complicated in practice. Every change to the propeller affected the aircraft system. Improper blade shapes could create vibrations tearing engines from mounts. Incorrect weight distribution could generate destructive harmonics. Miscalculated torque characteristics could render aircraft uncontrollable during takeoff. Republic Aviation needed propellers with significantly greater blade area that could integrate into existing aircraft without extensive modifications. Two companies competed to solve this challenge: Curtiss-Wright, manufacturer of the original narrowblade propeller, and Hamilton Standard, supplier of propellers for numerous military aircraft. Both understood that the winning design would be produced in quantities exceeding 10,000 units and would determine survival rates for thousands of American pilots. Engineers at both firms labored through the winter of 1943, testing blade shapes in wind tunnels, calculating stress loads, and building prototype hubs and pitch control mechanisms. American pilots were dying while engineers refined blade chord lengths and twist angles. Hamilton Standard developed a radical departure from conventional designs. Instead of thin knife-like blades, they proposed wide paddle-shaped blades that grabbed air like oars pushing through water. Blade chord increased dramatically. The blade remained almost rectangular along much of its length before tapering near the tip. Though it looked crude to engineers trained in traditional aerodynamics, wind tunnel testing revealed remarkable results. The design generated significantly more thrust at low airspeeds while sacrificing minimal top-end performance. Curtiss-Wright responded with their own wide blade design, maintaining a more conventional elliptical shape but dramatically increasing overall area. The Curtiss design featured blade cuffs at the root, smoothing airflow into the hub and reducing vibration. Both designs represented major improvements over the original narrow blades. Republic Aviation received prototypes from both companies in April 1943. Testing commenced immediately at Republic's facility and at Wright Field, Ohio. Test pilots evaluated both designs systematically. Results showed the Hamilton Standard and Curtiss propellers offered nearly identical performance gains. Climb rates improved dramatically. Hamilton Standard provided slightly smoother operation due to hydraulic pitch control, while the Curtiss design integrated more easily with existing aircraft systems, simplifying retrofits for P-47s already overseas. Neither was universally superior. The Army made a pragmatic decision based on production capacity. Both were approved for manufacturing. Hamilton Standard propellers would equip new P-47s produced at Republic's Farmingdale plant, beginning with the P-47D-22. Curtiss paddle blade propellers would fit P-47s built at the Evansville, Indiana factory and be supplied as retrofit kits for earlier aircraft in England. This dual-source strategy prioritized rapid deployment over exhaustive evaluation and also complicated German intelligence efforts. Production began in June 1943, but manufacturing and testing delays meant the first operational aircraft did not reach England until late December 1943. During December, P-47s were flown to RAF Wittering, where mechanics retrofitted them with new propellers. The 56th Fighter Group, operating from Bodney in Essex, completed the transition by early January 1944. Group Commander Lieutenant Colonel Hubert Zenke immediately recognized the tactical implications. Dramatically improved climb performance allowed his pilots to engage German fighters using vertical tactics that had previously been suicidal with narrow-blade propellers. Zenke organized intensive training through January 1944, developing new combat procedures specifically designed around the paddle blade Thunderbolt's enhanced climbing ability. He taught pilots to engage German fighters in climbing spirals, maneuvers that previously would have left them vulnerable. He developed techniques where pursuing P-47s would pull up sharply if enemy fighters tried to climb away, convert speed into altitude, then dive back onto targets with accumulated energy. With narrow blade props, these maneuvers would have left Thunderbolts wallowing at low speed. With paddle blades, they became deadly offensive tactics. January 4, 1944 marked a significant milestone. The entire 56th Fighter Group flew its first mission with all aircraft equipped with paddle blade propellers. Pilots immediately noticed the difference. Aircraft climbed with eagerness that seemed impossible for 7-ton fighters. Energy retention in vertical maneuvers improved dramatically. Thunderbolts could now follow German fighters into climbing escape maneuvers without losing position. The real test would come when they encountered the Luftwaffe over Germany. Combat debut came during escort missions in late January and early February 1944. American fighters encountered situations where German pilots executed standard escape tactics only to discover pursuing Thunderbolts matching their climbs. Initially, German pilots assumed they faced a new American fighter type. When intelligence officers examined gun camera footage clearly showing standard P-47 Thunderbolts achieving this performance, confusion spread through Luftwaffe units. How could the same aircraft they had successfully evaded for months suddenly match their climbing performance? March 6, 1944 provided dramatic confirmation. Lieutenant Colonels Burr led 48 Thunderbolts on bomber escort to Brunswick, routing over Berlin. Luftwaffe controllers vetoed more than 80 Messerschmitt 109s and Verwolf 190s toward the incoming bombers. As bombers approached at 24,000 feet, German fighters attacked using standard tactics, diving through formations, then pulling into steep climbs to escape escorts. Across the battle, Thunderbolt pilots matched German fighters in vertical combat for the first time.
Captain Robert Johnson.
Lieutenant Walker Mahurin and other 56th Fighter Group pilots caught German fighters in climbing engagements and
destroyed them at high altitudes.
The group claimed 11 victories without losing a single Thunderbolt.
More importantly, not a single bomber in their formation was shot down. German pilots landing after the Brunswick mission reported disturbing developments. American Thunderbolts were climbing with them. Multiple pilots
insisted they must have encountered a new fighter type.
When shown gun camera footage depicting
standard P-47s achieving described performance, confusion deepened. Luftwaffe technical intelligence needed to understand what had changed.
First clue came from wreckage analysis in early February. A shot-down P-47D-23 was transported to the Luftwaffe test facility at Rechlin. Engineers examining the aircraft immediately noticed the propeller blades were far wider than those on previously captured Thunderbolts.
The technical intelligence report described the new design, but initially failed to grasp its significance, concluding the modification likely improved takeoff performance rather than combat
capability. This misunderstanding cost the Luftwaffe valuable time.
Throughout February 1944, more P-47 groups transitioned to paddleblade propellers.
The 4th Fighter Group received theirs in early February. The 78th Fighter Group completed transition by mid-February. By month's end, 6 of 8 Thunderbolt groups in England flew paddleblade-equipped aircraft.
Each group immediately saw improved combat
effectiveness. German fighter losses climbed as Luftwaffe pilots found standard escape
tactics no longer worked.
On February 21, 1944, Jägerschwader 26 lost 7 Focke-Wulf 190s in a single engagement with the 56th Fighter Group.
Unit Commander Major Klaus Meadows filed an after-action report revealing frustration. His pilots had engaged according to established doctrine, disengaging through climbing attacks when pressed. Every pilot who attempted this maneuver was shot down. Meadows requested immediate clarification on whether Americans had introduced a new fighter type and whether existing tactical doctrine remained valid.
Luftwaffe intelligence had no satisfactory answer. German understanding improved through observation and wreckage analysis. By March 1944, Luftwaffe intelligence recognized that American engineers had
modified the Thunderbolt's propeller to improve thrust at low air speeds, particularly during climbs.
Reports circulated warning that American fighters could now contest vertical combat, recommending engagement only
when holding clear energy advantage and disengaging through level high-speed flight rather than climbing escape.
But
changing tactical doctrine across hundreds of fighter squadrons proved impossible. Pilots who had survived by
climbing away for the past year could not instantly reprogram survival instincts. The transformation scale became undeniable during Big Week.
The massive bombing campaign against German aircraft production facilities in late
February 1944.
From February 20 to 25, the 8th Air
Force launched over 3,800 bomber sorties escorted by more than 3,600 fighter sorties.
The vast majority of American fighters were paddleblade-equipped P-47s.
The Luftwaffe launched over 2,000 sorties in defense. Germans lost approximately
355 fighters destroyed with another 100 damaged beyond repair.
American fighter
losses totaled 28 aircraft. The exchange ratio had shifted dramatically. Thunderbolt pilots discovered that paddleblade propellers created opportunities beyond simple climb
performance.
Increased thrust at low speeds improved acceleration out of dives, allowing Thunderbolts to build energy faster after high-speed attacks.
Pilots could execute dive and climb
attacks repeatedly, maintaining initiative throughout extended engagements. Improved thrust also enhanced turning performance at slower speeds.
while Thunderbolts still could not outturn Messed 109s or Faller Wolf.
190s in flat horizontal turns, they could maintain sufficient energy in climbing turns to prevent German
fighters from gaining angular advantage. Major Francis Gabreski, commanding the
61st Fighter Squadron within the 56th Fighter Group, became the leading proponent of what pilots called the
climbing spiral. Gabreski would engage a German fighter at co-altitude, typically around 24,000 feet. Rather than attempting to outturn the enemy horizontally, he would maintain speed and pull into a climbing turn. German pilots, seeing the Thunderbolt climb, often followed, expecting the American fighter to lose energy and become vulnerable. But with paddle blade propellers, P-47s maintained climb rate even while turning. Gabreski would spiral upward through 2 or 3 full circles, gradually reducing the German fighter's energy state until the enemy stalled or was forced to break off. At that moment, with the German fighter at low speed and high altitude, Gabreski would reverse, dive onto the target, and open fire from a position where the enemy had no escape route. Gabreski ultimately claimed 28 aerial victories, flying P-47 Thunderbolts, making him the leading American ace in Europe, flying a single aircraft type. Nearly all these victories came after his squadron transition to paddle blade propellers. In post-war interviews, Gabreski consistently credited the new propeller as the single most important factor in the P-47's transformation. The modification required minimal changes to pilot training. Aircraft simply did what pilots wanted, maintaining energy in situations where narrowblade-equipped Thunderbolts would have failed. The paddle blade program represented American industrial capability operating efficiently. From initial concept to widespread deployment required only 9 months. 2 companies designed, tested, and began manufacturing 2 different propeller designs. Republic Aviation modified production lines at 2 factories. The Army Air Forces developed new maintenance procedures, trained mechanics, and shipped thousands of propellers across the Atlantic. No single aspect was revolutionary. The achievement lay in speed and scale of implementation. The United States identified a critical deficiency and corrected it faster than Germany could develop countermeasures. German aircraft designers possessed technical knowledge to create similar improvements. Both Messerschmitt and Faller Wolf employed experienced propeller engineers who understood theoretical benefits of increased blade area. But German war economy in 1944 could not support rapid modification programs. German aircraft production operated at maximum capacity, focused on producing existing designs in sufficient quantities to replace combat losses. Introducing new propeller designs would require retooling production lines, re-certifying aircraft performance, updating maintenance manuals, and training mechanics. Production disruption would cost thousands of fighters when Germany desperately needed every aircraft. Germans were trapped by strategic situation. They needed to match American improvements but could not afford the production disruption required. This highlighted fundamental differences in American and German approaches to aircraft development. American designers accepted good enough solutions implementable quickly. The paddle blade propeller was aerodynamically less efficient than more sophisticated designs. It created more drag than narrower blades at high speeds. It was heavier, requiring reinforced hubs and pitch control mechanisms, but it solved the immediate problem without requiring years of development to optimize every parameter. German designers often pursued theoretical perfection at the expense of practical implementation. German propeller designers worked on advanced variable pitch systems that would theoretically outperform crude American paddle blades, but these advanced designs existed primarily on paper, never reaching operational service in meaningful numbers. By March
1944, the paddle-blade Thunderbolt had become the standard American escort fighter in Europe.
The aircraft was no longer a compromised platform, awaiting replacement by longer-ranged P-51 Mustangs.
The Thunderbolt had evolved into a formidable air superiority fighter, dominating German opponents in most
combat situations.
The psychological impact was significant.
American bomber crews who
had watched helplessly as German fighters climbed away throughout 1943
now saw enemy fighters chased down and destroyed in climbing combat. German
pilots, already demoralized by increasing American numerical superiority, faced a
tactical environment where their advantages had been neutralized. The Fula Wolf 190, designed as superior to
the Thunderbolt in nearly every performance category, found itself matched or exceeded in the one area
where it maintained clear superiority. The Messerschmitt 109 could no longer rely
on vertical maneuvers to escape combat.
German fighter losses climbed steadily through spring 1944. Many veteran pilots who had survived years of combat were shot down by Thunderbolts they thought they had successfully evaded. The full impact became evident during preparation for D-Day.
Throughout May 1944, American fighters conducted intensive
operations aimed at achieving air superiority over France. Thunderbolts ranged across northern France, attacking German airfields, destroying aircraft on
the ground and engaging any Luftwaffe fighters that attempted interference. Paddle-blade-equipped P-47s proved especially effective in these fighter sweeps. When German fighters scrambled to intercept, they typically climbed from lower altitudes to reach American fighters operating at 20,000 to 25,000 foot. Thunderbolts could now dive on these climbing German fighters, attack, then
climb away before Germans could retaliate. June 6, 1944. As Allied forces stormed Normandy beaches, Thunderbolts provided air cover throughout the day. German fighters that attempted to attack the invasion fleet or support German ground forces were consistently intercepted and destroyed by paddle-blade-equipped P-47s. The Luftwaffe managed fewer than 100
sorties over invasion beaches during the critical first 24 hours.
American fighters flew more than 8,700 sorties during the same period. This
overwhelming superiority was possible because American fighters achieved kill ratios of 4-to-1 or better. The paddle-blade propeller, by eliminating the Thunderbolt's primary weakness, contributed directly to achieving air superiority that made invasion possible.
Statistical evidence
supported what pilots experienced.
In first quarter 1944, before paddle-blade
propellers became widespread, American fighters in Europe achieved overall kill ratio of approximately 1.8-to-1 against
German fighters. By second quarter 1944, with most
American fighters equipped with paddle blades, kill ratio improved to 3.2-to-1. By third quarter, it reached 4.6-to-1.
These improvements cannot be attributed solely to propeller modification.
American numerical superiority was increasing, pilot training improving,
and Germany fielding inexperienced pilots to replace mounting losses. But
combat reports make clear that improved climbing performance played significant roles in these victories.
The Curtiss Electric C-542S paddle blade propeller, the most widely used variant, featured 4 blades with 13-foot diameter. Each blade had significantly increased area compared to narrow blade predecessors. This substantial increase translated to dramatically improved thrust at low air speeds.
The Hamilton Standard Hydroatic paddle blade fitted to later production P-47s offered similar performance with operational advantages.
The Hamilton Standard design used hydraulic pitch control that was simpler and more reliable than the Curtiss electric system. Total blade area was nearly identical and combat performance was indistinguishable. Manufacturing effort required to equip
The P-47 fleet demonstrated American industrial capacity operating at scale. Both Curtiss-Wright and Hamilton Standard produced thousands of propeller assemblies between June 1943 and December 1944. Each consisted of 4 blades, hub assembly, pitch control mechanism, and mounting hardware. Blades were forged from aluminum alloy, machined to precise airfoil shapes, and heat-treated for maximum strength. Each blade required approximately 14 hours of machine time, not including raw material preparation and finishing operations. Distributing these propellers to operational units in England presented logistical challenges. Each assembly weighed approximately 650 pounds and required careful handling to prevent damage during shipping. Propellers were packed in wooden crates with protective bracing and shipped across the Atlantic on cargo vessels. Voyages typically required 2 weeks. Upon arrival, propellers were transported to air depot facilities where mechanics installed them on aircraft. Installation required approximately 16 hours per aircraft, including removal of old propellers, installation of new ones, rigging pitch control systems, and conducting ground tests. Between January and June 1944, air depot mechanics in England retrofitted over 1,000 Thunderbolts while maintaining operational readiness of frontline fighter groups. Tactical evolution of paddle-blade Thunderbolt operations continued through summer and fall 1944. Pilots developed increasingly sophisticated techniques to exploit improved climbing performance. 1. Particularly effective tactic was the vertical scissors, where 2 Thunderbolts would engage a German fighter in climbing dogfight. As enemy aircraft climbed to escape one P-47, the second would position to attack. As soon as the German fighter lost energy and could no longer climb effectively, the German pilot faced impossible choice: continue climbing until stalling, making him easy target for the trailing Thunderbolt, or roll out to maintain airspeed, allowing the lead Thunderbolt to execute diving attack. Another significant development was use of paddle-blade Thunderbolts for low-altitude ground attack missions. Improved thrust at low speeds allowed heavily loaded P-47s to maintain speed and maneuverability even when carrying 2,500 pounds of bombs or rockets. Pilots attacking German ground targets could enter attack dives from lower altitudes, reducing exposure time to anti-aircraft fire. After delivering ordnance, paddle-blade-equipped Thunderbolts could climb away from target areas more rapidly, again reducing vulnerability. Between April and September 1944, Thunderbolts flew more than 88,000 ground attack sorties while suffering approximately 820 losses to all causes, a loss rate of less than 1%. The versatility of paddle-blade Thunderbolts allowed them to remain in frontline service even as longer-ranged P-51 Mustangs became available. Many fighter groups chose to retain Thunderbolts specifically because improved performance made them exceptionally effective in multiple roles. The 56th Fighter Group, commanded by Colonel Hubert Zanka and later Colonel David Schilling, flew Thunderbolts exclusively throughout the entire war. Despite opportunities to transition to Mustangs, the group's pilots believed the rugged construction and 8-gun armament combined with excellent climbing performance provided by paddle-blade propellers made it superior to the Mustang for their operations. German fighter pilots who survived the war consistently mentioned the paddle-blade Thunderbolt as one of the most capable American fighters they faced. Major Gunther Rall, who survived with 275 victories, noted in post-war interviews that improved Thunderbolts were far more dangerous than earlier versions. Our stated German pilots had to treat paddle-blade Thunderbolts with the same respect they accorded P-51 Mustangs, recognizing the American fighter could match German performance in most combat situations. Engineering lessons learned from the program influenced American aircraft development throughout the remainder of war. Rapid development and deployment demonstrated that incremental improvements to existing aircraft could often provide better value than developing entirely new types. The P-47 itself benefited from continued
improvements beyond propeller modification. Water methanol injection systems.
Increased engine power to 2,535 horsepower for short periods.
When combined with paddle blade propellers improved thrust characteristics, this further enhanced performance. The P-47M, introduced in late 1944, incorporated both modifications and could climb
rapidly, matching or exceeding climbing performance of any German fighter.
The financial investment required to develop and deploy paddle blade propellers was modest compared to operational benefits achieved.
Development costs for both Curtiss and Hamilton standard propellers, including wind tunnel testing, prototype construction, and flight testing, totaled approximately $3 million. By comparison, developing an entirely new fighter aircraft would have cost at least $100 million and required 2 to 3 years before reaching operational service. The paddle blade propeller represented exactly the kind of cost-effective improvement that made American air power difficult to match. Paddle blade propellers also highlighted importance of feedback loops between combat operations and aircraft development.
Problems with narrow-blade propellers were identified by frontline pilots who filed after-action reports describing
German fighters escaping through climbing maneuvers. These reports filtered through intelligence systems to reach engineers who could diagnose root causes and develop solutions. This feedback loop operated relatively quickly, with problems identified in combat leading to engineering solutions within months.
German forces had similar feedback systems in theory, but found them increasingly disrupted by chaos of Germany's deteriorating strategic position.
Strategic impact extended beyond direct air combat.
Achievement of
air superiority over Europe, to which improved Thunderbolts contributed significantly, allowed Allied ground forces to advance with minimal interference from German air power.
During breakout from Normandy in August
1944, American ground forces advanced under umbrella of air superiority maintained
largely by Thunderbolts.
German ground forces attempting to retreat or reposition found themselves under constant attack from Allied fighters.
Improved climbing performance meant German fighters that attempted to
interfere with ground attack missions could be quickly intercepted and destroyed by escorting P-47s.
Final major air combat involving large numbers of paddle blade Thunderbolts occurred during Battle of the Bulge in December 1944 and January 1945.
When German ground forces launched surprise offensive through Ardennes, bad weather initially prevented effective air operations. When weather cleared on December 23, Allied air forces launched massive attacks against German ground forces and supply lines. Paddle blade-equipped Thunderbolts flew hundreds of sorties daily, attacking German armor, trucks, and artillery positions. Luftwaffe fighters attempted to interfere, but were consistently driven off by escorting P-47s. By February 1945, organized Luftwaffe resistance over Western Europe had effectively ceased. German fighter units were being withdrawn to defend homeland against increasing strategic bombing campaign. Paddle blade Thunderbolts had played significant roles in achieving this air superiority, though their contribution was overshadowed by more glamorous reputation of P-51 Mustangs. Military historians examining the air war have sometimes downplayed the Thunderbolt's importance, noting P-51s achieved more aerial victories and flew deeper into Germany. But this misses the critical point that Thunderbolt transformation through paddle blade propeller modification came at crucial moment when German fighter forces still represented formidable threats. Between January and December 1944, Thunderbolts were credited with destroying 382 German aircraft in aerial combat while losing 824 P-47s to all causes in European theater. This represented overall kill ratio of 3.7 to 1, comparable to or better than other American fighter types during same period. More importantly, Thunderbolt transformation from mediocre climber to capable vertical fighter occurred during period when such capability was most desperately needed.
Post-war fate of paddle-blade Thunderbolts reveals how quickly wartime innovations can be forgotten. As jet fighters
entered service, propeller-driven P-47s quickly became obsolete.
Most surviving
Thunderbolts were scrapped or sold to foreign air forces.
Technical achievements that made paddle-blade
Thunderbolt's effective fighters were eclipsed by revolutionary capabilities of jet propulsion. Few aviators who flew upgraded Thunderbolts in combat later advanced to roles where they could ensure the propeller modification received proper historical acknowledgement.
Yet paddle-blade propellers represent a fundamentally significant form of military innovation that warrants broader recognition.
It was not a revolutionary breakthrough that altered the basic nature of aerial combat. It was an evolutionary enhancement that took an existing aircraft and removed its most critical vulnerability through relatively straightforward engineering. This kind of improvement, less dramatic than entirely new technologies, but often more immediately effective, defined much of American military success during World War II. The ability to identify deficiencies, devise practical solutions, implement them quickly, and deploy them at scale provided American forces with decisive advantages. The engineering concepts underlying paddle-blade propellers remain relevant to contemporary military aviation despite the transition to jet propulsion. The essential principle that blade area must be matched to operational conditions rather than theoretical maximum efficiency applies to turbine blades, helicopter rotors, and unmanned aerial vehicle propulsion systems.
Military engineers continue to confront the challenge of balancing multiple performance requirements across varying flight regimes. The German perspective on paddle-blade Thunderbolts offers sobering lessons regarding the consequences of industrial and strategic weakness. German engineers understood propeller theory as thoroughly as their American counterparts. German aircraft factories were capable of producing improved propellers if given the resources and opportunity.
However, Germany's deteriorating strategic situation, material shortages, and increasingly disrupted industrial base made rapid improvement programs impossible.
Paddle-blade Thunderbolts succeeded not because American engineers were inherently superior, but because American industry could sustain rapid innovation while German industry could not. Wars are not won by single wonder weapons, brilliant tactics, or revolutionary devices alone.
They are won by the cumulative impact of thousands of incremental enhancements, each addressing a specific problem, each implemented efficiently, and each contributing to overall superiority. The paddle-blade propeller was one such improvement among many, but it arrived at a pivotal moment when German forces were still capable of contesting Allied air dominance.
By eliminating the Thunderbolt's primary weakness, this modification helped secure aerial supremacy, enabled the invasion of Europe, and hastened Germany's defeat.
This accomplishment, born from the steady work of propeller engineers rather than dramatic feats of fighter pilots, deserves recognition as one of the decisive technological contributions to Allied victory in Europe.